In this video, let's see how to interface LEDs and switches with 8085 microprocessor. Here, let's consider 8 switches which is interfaced with the 8085 and transferring the status of the switches to 8 LEDs. So, in order to do this interfacing circuit, 2 ports are required. One port is required to interface LED and another port is required in order to interface switches. Here, MUPI need to read the status of the switch position and that status need to output to LED. So, one port should be input in order to read the status of the switch and next port should be output port to display the output using LEDs. Let's consider port A as output port and port B as input port. So these 2 ports are only required for this purpose. So remaining port, that is port C, may be input or output. Let us take port B as output port. So in order to make port A as output port B as input port and port C as the output port, we need to load corresponding control word format in control word register. Control word format is this one. As we are considering operational mode as IO mode, this D7 bit is 1. Next 2 bits determine modes of operation. Here we are using mode 0. So these 2 bits is 0. Then port A is output. So it is 0. Then port C upper is output. It is also 0. This one is mod B. Mod B is in mod 0. So it is 0. Then port B is input port. It is used for receiving the status of the switch. So it should be 1. And port C lower is 0. That is output port. When we are converting this into hexa, we can obtain that value as A2. So in order to make port A as output port, port B as input port and port C as output port, we need to write this code, that is MVI A,82H. Then that number we need to load into control word register. We can have control word register address as 03. So by means of out 03 instruction, the content of accumulator, that is 82H. What is 82H? This is the control word in order to make port A as output, port B as input and port C as output. That will reach into control word register. After execution of this instruction, port A become output port, port B become input port and port C become output port. Then we need to read the status of the switch. Switch is connected in which port? Switch is connected in B port. So we need to read the status of B port. How to read the status of B port? We can use in01. Whenever this instruction is executed, content of the port address 01 is loaded into accumulator. So what is 01 address? 01 address is the address corresponding to port B. So the status of port B is reached into accumulator that I can out by means of port A by means of this instruction. The content of accumulator is loaded into the specified port address. Here 00 is the address corresponding to port A. So whatever be the content of port B, that is transferred into port A by means of these 2 instructions. This reading and writing into port A process we need to repeat. For that we are using an unconditional jump instruction, jump loop, so that it will read the status of B, out that into A, that process will repeat. So this is the program in order to interface LEDs and switches with 8085 microprocessor, and this is the corresponding circuit. Here the data is bidirectional. 8085 data bus is directly connected to data bus of 8255. Here A0 and A1 is used for selecting port and control word register. RD bar and WR bar is used for read and write operation, and reset bar signal of these 2 things are connected. As seen here, port B is connected to 8 switches and port A is connected to 8 LEDs. And in order to create a CS bar signal, we can use the remaining address lines along with IO by M bar signal. IO by M bar signal is already 1. Why? Because IO operation is carried out For IO operation, IO by M bar is already 1 and remaining pins A2 to A7 are zeros that we need to complement by means of NOT gate like this. So by means of NAND logic, we can obtain an active low CS bar signal in order to activate 8255 IC. So this is the complete interfacing circuit in order to interface 8 switches and 8 LEDs with 8085 microprocessor using PPI 8255 IC.